Welcome everyone to today's explainer. Look, if you're architecting or securing enterprise cloud environments right now, you already know that speed is the absolute mandate. But trying to secure thousands of containers moving at light speed, well, that's exactly where things usually break down. Operating modern cloud-native environments securely at scale really requires a fundamental shift in how we think about risk. So today we're taking a consulting-style look at exactly why DevSecOps has become the non-negotiable operational standard. Okay, let's dive into this. Here is our executive agenda. We'll start with velocity versus legacy security, then move beyond basic pipeline scanning. After that, we'll cover platform engineering and governance, building a DevSecOps culture, and finally, scaling secure cloud operations. All right, kicking things off with Section 1, velocity versus legacy security. Because modern engineering velocity fundamentally breaks those older security models. Let's think about traditional legacy security for a second. It relied on isolated teams, manual review boards, and injecting these massive security checks right before deployment. I mean, think of the dreaded 3-week wait for a change advisory board approval. It inherently creates massive operational friction. Compare that to modern DevSecOps. It's integrated, it's continuous, highly automated, and embedded directly into operations. If you try to force modern engineering through those old isolated review boards, the business's operational speed will literally outpace your security team. No question. The reality of modern cloud-native velocity is just staggering. Enterprises today are tearing down and spinning up Kubernetes clusters, they're running automated CI/CD pipelines, and relying heavily on infrastructure as code, like Terraform. And all of this happens in minutes, not months. Operating without integrated security practices in these highly ephemeral environments, it practically guarantees a loss of visibility, broken governance, and some massive compliance headaches down the road. Which brings us to Section 2, beyond basic pipeline scanning. Because true DevSecOps is a massive shift in mechanics, actually, not just some simple plugin. So the crucial point is this. One of the biggest misconceptions in enterprise cloud architecture is assuming that DevSecOps just means dropping a vulnerability scanner into your CI/CD pipeline and calling it a day. The true scope required for modern operations is so much broader. We are talking about comprehensive policy enforcement, zero-trust network architectures, and really robust runtime security. You need strict, dynamic secrets management, hardened workload isolation, and continuous operational monitoring. Successful DevSecOps integrates into the entire platform lifecycle, well beyond just a basic build time scan. And that leads us to a massive challenge. How do we prevent operational drift across multi-cloud environments without blocking developers? When you're scaling Kubernetes and hybrid cloud architectures at breakneck speeds, relying on manual security checks is a guaranteed way to introduce dangerous operational drift. And let's be real, that drift is exactly where breaches happen. So, how do we solve that? Let's get into Section 3, platform engineering and governance. This is the enterprise solution to that friction and drift problem. As platform engineering becomes the standard for enterprise cloud operations, building an internal developer platform, or IDP, becomes absolutely critical. Platform teams create these secure, golden paths for the wider engineering organization. And security must be embedded directly into these platform templates, especially infrastructure as code. By automating compliance directly within CI/CD pipelines and standardizing IAM by design, things like infrastructure validation, secrets rotation, and policy consistency, they happen automatically, literally zero extra effort from the developer. But wait, preventative templates aren't a silver bullet. Mature cloud environments demand real-time visibility. We need to track workload behavior, identity usage, network activity, and infrastructure changes the exact second they happen. This is exactly why DevSecOps and modern observability platforms are converging right now. You simply cannot secure what you cannot see, right? And your operations increasingly depend on observability to detect runtime anomalies instantly. Okay, let's pivot for Section 4, building a DevSecOps culture. We're shifting focus from the technical mechanics to the critical human element. Now, what's really interesting about this slide is that DevOps is, at its core, a mindset designed to break down silos and deliver value faster. But true operational alignment means fully adopting a security shift-left mentality. Building security in from the very start isn't just a matter of buying a fancy new tool set or spinning up Kubernetes and mission controllers, it's a core operational practice. Dev, security, and ops teams absolutely must collaborate around these shared standards and governance models for any of this automation to actually work. Because it really comes down to this. Tools enable DevOps, but culture makes it sustainable. You can have the most advanced automated CI/CD pipelines and the strictest Kubernetes governance in the world, but cross-functional collaboration is what actually enables secure operations at scale. Organizational alignment around shared visibility and unified operational controls, that is the secret sauce to making this scalable and sustainable over the long haul. All right, bringing it all home with Section 5, Scaling Secure Cloud Operations. Let's look at the direct business value and operational payoff. Let's map these DevSecOps practices directly to their enterprise benefits. When we automate compliance and standardize security through platform templates, the organizational payoff is just immense. Deployments become highly predictable, which drives up reliability. Standardized security drastically decreases daily friction for developers. And those platform templates? They provide automated drift prevention across incredibly complex multi-cloud environments. Compliance basically transforms from a painful manual audit into just a seamless byproduct of your everyday engineering process. And this brilliantly illustrates our main takeaway: enablement. The best DevSecOps models enable developers instead of acting as gatekeepers. When security becomes standardized, automated, and embedded into the internal developer platform itself, operational friction drops to near zero. Engineering teams can move incredibly fast without breaking things. By engineering security right into the platform lifecycle, you are actively improving developer productivity and driving overall engineering velocity completely safely. I'll leave you with this final provocative thought to consider for your own enterprise cloud environments. Ask yourself, are your security processes acting as an isolated roadblock, or are they engineered into the very fabric of your continuous platform lifecycle? I really challenge you to rethink your organizational bottlenecks and transition away from legacy, isolated review processes toward truly automated, scalable cloud operations. Thanks so much for joining me for this explainer. Keep building securely.